After all that talk we just had on how vector triangles work, ironically, we're not actually going to get into that just yet. With this next set of videos, we're just going to hone in on relative motion, something that wasn't really relevant in the set and drift problems, but is really important all throughout radar. It's the only thing you're directly observing. Everything else is calculated off of that or is provided to you to begin with. The relative motion is what you actually see off of the radar display. And the way we're going to do that is by imagining we're actually taking a measure, or I don't even know what to call it, taking observations on the scope. A big problem people have when they're taking their introductory radar classes is they have the mindset that you need to get through the class, because in the class they hand you a sheet of paper and they say at this time the contact bore this bearing at this range, and then at this time it bore this bearing at this range, and so on, and you just plot it down. It's not what you would be doing in real life. Obviously, you don't have that information provided to you. You'd be sitting on the radar, you'd see a contact, and you would wait until you got to, whatever time you chose. So you'd wait until you got to the minute. If it was 1530 seconds, you'd wait to 1501, and then you would measure based on an EBL or a VRM, concepts that you'll get into when you're practically using radar. Is something I can't teach because I don't have a radar console with me. But you would basically just measure the bearing and the range of the contact at exactly 1501, and then you would wait. And you would wait a decent amount of time, because if you wait 2 minutes, it's not really enough time to measure a good distance. If you wait 30 seconds, that's definitely not enough time. If you wait 30 minutes, you would get a really accurate motion between the two, but that's probably too much time, and it might have already hit you by then. The golden rule is to wait 6 minutes, or somewhere around then, preferably exactly 6 minutes. Because if you wait exactly 6 minutes, you can apply the 6-minute rule. You just multiply their distance by 10 and you get their speed. Because the Navy uses yards, and because the Navy uses Mo boards, which have a much easier time scale than the radar plotting sheets, they don't necessarily stick to that as much. They might just use 3 minutes, but then wait another 3 minutes. They might use they can use 5 minutes. It doesn't matter as long as you're using the plotting sheet well. But let's say we're using 6 minutes to stay smart with it, because that is always the best time frame. It's long enough that you're going to get a accurate sample between the two, and it's easy enough that you can double check yourself in case the plotting goes wrong. So let's say you are looking on your radar, and at time we'll label this contact A, even though in this situation we're only going to have one contact anyway. At time 1500, like we said, contact A bore 034 at a range of 8.3 nautical miles. We're going to use nautical miles in this. All right, so you got that off the radar scope. You measured over, you put your cursor, you put the EBL VRM on the contact, and you got 034 at 8.3 miles at 1500. Good. Now that you've done that, we actually come over to plot it, because you have 6 minutes until you have to take the next shot. So in those 6 minutes, what you're going to do is you're going to get your triangle or your parallel plotter. It doesn't matter. You're going to measure out 034. You can see here's 30 and 40. This larger tick mark, those are on the 5s, and then you've got all the 1s next to them. So 034 would be the mark just next to the 1. You would connect that to the center of the scope. And you would line it up to be nice and clean, and then you would just draw a line. It doesn't need to be thick. It can be nice and faint. I usually draw them really faint, and then I'll fill it in later. And it also doesn't even need to go all the way to the center of the scope. You'll see why in a second. Unless you're plotting a target that's right over here, it doesn't need to go there. As long as you keep your tine right at the center. And so then it had a distance of 8.3 miles. So you measure out to the 8, then you come to 8.3 right there. Then you keep that in position, swing this over, and if it was a compass, you'd take a sweep across, and it would mark that point perfectly. Because I only have dividers, I'm just gonna like prick the chart a little bit there, prick the paper, and then mark it again with my pencil. And then we would circle that, darken it a little bit so it's nice and clean. We could erase everything around it because that all doesn't matter. And then what we're going to label this is M1. Okay. Now, if I weren't explaining it, that probably could have been done in like 10, 15 seconds without a problem. But this is just the graphical representation of this information. At 1500, our contact bore 034 at 8.3 miles. Now that that's come by, after you finish plotting it, you just stand by and wait. You head over to your radar again, and you're ready for the next fix. And again, it doesn't matter exactly how long you wait. If you wanted to wait 8 minutes, 8 minutes is fine. However, the best practice is to wait exactly 6 minutes. Wait until exactly perfectly 15:06, and then you take another shot. And let's say at 15:06, it bore 036 at 7.6 miles. I'm making these up as I go. If it comes out weird, it comes out weird. I'm just making it up. But at 15:06, we bore 036 at 7.6 miles. Now, for one thing, the most stressful part is over because it is kind of stressful to wait till you're exactly 6 minutes from the last measurement. Now that that's over, you just got to plot this next position. So you place the triangle at your center of your scope, and then you come down to 036, which was just on the other side of the 35 center mark here. You draw a nice faint line, and then you measure out 7.6 miles. So you come to the 7, come up to 0.6 right there. You swing across, you mark it with your compass. For me, I have to fill it in again because I don't have a compass. Darken it, circle it. You don't even necessarily have to circle it, but that's what I was always taught. And you label that M2. And as you can see, if you wanted to, you could wait every 6 minutes, get an M2, an M3, an M4, and so on to track it across the scope as it goes. However, you don't necessarily need to do that because once you have these two and the relationship between them, you'll be able to predict out into the future where they're going. But let's not get ahead of ourselves. We're going to practice that again with a different contact. So let's say in this problem there was another ship somewhere to the south of us, to the southwest of us. And we took its shots. Now, realistically, you would not be able to take these shots at 1500 and 1506 and then do the same for these ones over here. You're going to have to wait a little bit between the two. So let's say that when you were tracking both of these contacts, you took that one at 1500. Then at 1501, you took a shot of the contact down here. We're going to label it B. And it bore 231 at 7.1 miles. So you come here, you plot 231 like so. There we go. You measure out 7.1 miles. And that's M1 for contact B. Then at 15:07, so still 6 minutes apart, just 6 minutes offset by a minute, it bore, let's say 230 at 6 miles. 6 miles exactly. 230 is nice because you don't even actually have to draw a line here. You can just use the line that's already plotted. So you could, and you actually don't have to measure anything at all. You could just say, here's the 6 mile ring. And you know one little tick mark past the 6 is 6.1. And you know that we're on the 230 line here. So you can just mark it directly there and get M2. So that is how you mark, how you monitor contacts and just slowly place their positions relative to you on the maneuvering board. Remember, it doesn't always have to be 6 minutes, but 6 minutes is the best one to use. We'll get into why later. All it needs to be is some substantial amount of time. Substantial being more than three or more minutes. Less than that, and any minor fluctuations in, you know, the wind and seas might show it slightly different. Your yawing of your ship might make it slightly less representative. After 3 minutes, though, it should be good enough that you could probably work with. Anything more than like 10 minutes, though, and it might have changed course in that time. So 6 is really the Goldilocks zone.